So in this video, I'm going to be looking at introducing simultaneous equations. So one of the most common questions we tend to get asked is, why are we learning this? So simultaneous equations are very much prevalent in everyday life. For example, if we're looking at comparing information, for example, comparing the average speed of riding your bike to school versus walking to school, or even comparing plans, like mobile phone plans between providers, can be done using simultaneous equations. We use them to identify profit and loss. So for example, a business might look at how many units they need to sell in order to make a profit, how many they will need to break even, or even how many units they'll sell in order to make a loss. Air traffic controllers also use simultaneous equations to ensure that two planes don't intersect at the same time. So in terms of what they tell us, basically with a simultaneous equation, and when we graph them, it tells us where two or more graphs meet, and we call that intersect. So for example, if a business wanted to develop two equations, one for revenue and one for cost, we would say the point at where those two equations meet is what we call the break-even point. So what we can do here is we can solve for solutions using a few different methods. The most time-consuming method is probably the trial and error method, and that's basically where you substitute different values for x into each equation and y, or whatever our variables are, in order to determine where the two graphs meet. Another method we could use is graphical. We could use substitution, and we can use elimination. In this particular video, we're going to be focusing just on substitution and elimination. However, we will in future tasks be looking at using the graphical method as well. So the core idea here is that when we solve a set of simultaneous equations, what it means is that we're trying to find a solution that satisfies both equations. So I think that's really important to remind you, is that it's finding a particular solution that satisfies both equations. So not just one, but both. In the event that you have more than two equations, the set of solutions that you're finding need to satisfy every single equation you've been given. For the purpose of the Year 10 course, however, we're only focusing on two equations. Now, one of the questions I'd like to pose to you is, why is it that when two lines are parallel, there is no point of intersection? So I just want you to have a think about that. And in the meantime, I'm going to show you guys a graphical representation of two equations. And if you look at where the green and blue equations meet, so this particular point here is what we call our point of intersection. So this is where the two equations meet. Now let's say the green line represents profit for a company and the blue line represents cost or expenses. Then you can see that at the point of intersection, this is what we call our break-even point. And what you can see is that the green line up until our break-even point is actually lower than our cost line, which is the blue one. But you can see once they hit the break-even points, that's when both our profit and cost are equal to each other. Our revenue. Our green line's called revenue. You can see that once that point is hit, all of a sudden our revenue is going to be a lot higher than our cost. So what that means is that anything below the break-even point is what we're going to call a loss, and anything above the break-even point is what we're going to call the profit. So obviously we will be exploring this in some more detail later on, but just keep in mind that this is an example of how we could use simultaneous equations outside of just maths. Now, if we come back to the question that I posed to you, which is, when two lines are parallel, there is no point of intersection, and why could this be the case? I thought it'd be good to actually have a look at an example. So what I've got here is two very different equations, and you can see that they're parallel. So I'm just going to write here, obviously from observing, we know that they're parallel, but if you think about the feature of a parallel or two parallel lines, the defining feature here is that the gradients are actually the same. Now remember, the gradients also dictate how steep or basically how steep a particular line is. So the fact that the gradients are the same is what actually causes these two graphs to never meet. So due to this, parallel lines don't intersect. So that is basically us sort of drawing back on our earlier understanding of linear and when we talked about parallel and perpendicular lines. So now what I'm going to do is I'm going to move on to introducing substitution. For some this will be a revision, for some this will be brand new, and that's completely okay. So the prerequisite here is that at least one of the equations needs to have a pronumeral as the subject. So again, just remember that. We will need to substitute one equation into the other, and then we can go on to solve that equation. So let's have a look at the worked example. So what I like to do is I actually start by numbering my graphs, or equations, sorry. So say that's 1 and that's 2. Now what I'm going to do here is, you can see that this particular equation has a pronumeral as the subject, and the subject is y. So what I'm actually going to do is substitute equation 2 into equation 1. So what that's going to look like is the following. So I'm going to have 3x minus 5 times x plus 5 equals negative 15. So then, just like we know how to, we're going to expand this bracket here. So we're going to have 3x minus 5x minus 25, because obviously negative 5 times positive 5 equals negative 15. Now, combining my like terms together, I've got 3x minus 5x, which is negative 2x. Taking that 25 to the right-hand side, I'm going to have negative 15 plus 25. So that's going to give me negative 2x is equal to 10. And then dividing both sides by negative 2, they'll cancel out. So I've got x is equal to negative 5. So what that's telling me right now is that when these two lines meet, it's when x is equal to negative 5. However, we know that's not complete yet, because obviously we need to work out what the y value is, or to complete this set of coordinates. So now what we can do is, to find y, we can substitute x equals 5 into either equation 1 or equation 2. So to make it easy, I'm going to substitute it into equation 2. If you choose to put it into equation 1, that is completely fine, and you will get exactly the same answer. So where y is equal to x plus 5, I'm going to sub in x equals negative 5. So I've got y is equal to negative 5 plus 5, so y is equal to 0. So now if I put this or write it out as a coordinate, I'm saying that at this particular point, this is when both graphs intersect. Now, what I did was I actually graphed both equations on Desmos. And what you can see here is that the blue line is y equals x plus 5, and the red line is 3x minus 5y equals negative 15. And what you can see is that these two graphs, where they meet, is exactly what we just calculated. It's when x is equal to negative 5 and y is equal to 0. So that is our point of intersection. So the substitution method, is one of the more easier methods. So we tend to use this method when both equations are written in the form ax plus by equals c. So I'm just going to highlight that as well. Again, not always the case, but generally speaking, we tend to use elimination when it is written in that form. So let's take a look at this example here. So we've been asked, to solve this pair of simultaneous equations using the elimination method. So I'm going to write here, or I'm going to number my equations again. And what I tend to do is actually write them like this. So 2x plus 4y equals 3. So what you can see here is that when it's written like this, or when both equations are on top of each other, you can see a lot easier what you can eliminate. So what I'm going to do here is I'm going to eliminate 4y because it is common to both equations. So I'm going to do that by subtracting them. So I'm subtracting equation 2 from equation 1. So I'm going to cancel that out. And what I'm going to be left with is 2x minus 3x is negative x. And then 7 minus 3 is 4. So x is equal to negative 4. So what I'm going to do now is substitute x is equal to negative 4 into equation 1 or 2. And really what we recommend you do is substitute it into the easiest equation that you see. Sometimes neither will be the easier option. Sometimes it's pretty clear what will be. When I say easy, I'm just talking about a question you think, or equation, sorry, you think will require the least amount of working out. I'm just going to choose equation 1 for this. So I'm going to substitute x is equal to negative 4 plus 4y equals 7. So expanding this now, I've got negative 8 plus 4y equals 7. So I'm going to write 4y is equal to 7 plus 8. So 4y equals 15. And then solving for y, I've got 15 divided by 4. So that means when x is equal to negative 4 and y is equal to 15 on 4, that's when these two equations meet. So if we take a look at the graph here, basically our point of intersection is what we just solved for. So that's going to be negative 4 and then 15 on 4. Again, what you can see here is that the gradients are different for both equations, and given that that's sort of what dictates, what dictates how steep both equations are as well. So now I'm going to move on to another example where we're using the elimination method, but this one will require a little bit more work than the previous example. So what you can see here is two different equations. So I'm going to say 2y plus 5x equals 13 is equation 1, and then y minus 3x equals 1 is equation 2. So if I write them the way that I did before, so like in a stacked method, what you can see here is that there's no actual pronumeral that I could cancel out or eliminate. I do have to do a little bit more work to this. So what I'm actually going to do is I'm going to look to cancel the y. So I can do that by multiplying the entire equation by 2. So what that's going to leave me with is 2y minus 6x equals 2. So I'm just going to write the first equation above this. So 2y plus 5x equals 13. So now I'm going to deal with these two new equations. One new equation and our original. So now we can eliminate y. So they cancel out, and we do that by subtracting both equations. So then I've got 5x minus negative 6x. So dealing with that, I'm going to get 11x. 13 minus 2 is going to give me 11 as well. Now solving for x, we've got 11 divided by 11, so x is equal to 1. So now that I've got my x value, I can work out y. So I'm going to substitute x is equal to 1 into equation 2. So I'm going to do y minus 3 times 1 equals 1. So y minus 3 is equal to 1, so y is equal to 4. So that means when x is equal to 1 and y is equal to 4, both lines will intersect. Now if we take a look at this graph here, we can see that that's 1 and that's 4. So that is our point of intersection at 1, 4. Now, if I hadn't asked you to use the elimination method, with this particular question, I probably would have used the substitution method. So I'm just going to do that quite quickly here. And basically for this particular method, I would rearrange equation 2 because that would have been the easiest thing to do, which is to make y the subject. So I'm just going to write Alright, so writing out the two equations again. So now here you can see that I can substitute equation 2 into equation 1. So I'm just going to quickly finish that off. So we've got 2 times 1 plus 3x. So again, you can see here that I got exactly the same set of coordinates. So hopefully this should show you that regardless of the method you use, you will arrive at the same answer. It just depends on what your preferred method is. Again, if the question specifically states that you need to be using the elimination method, then make sure that that is the method you use. Or if we say to use the substitution method, then make sure that's the method that you use. While you are in the practice phase of this, I would encourage you to use both methods and get practicing on using elimination and then using the substitution method. So that's the end of this particular video. Hopefully you're feeling comfortable with being able to solve simultaneous equations. Remember, again, practice is always the way to go. And here all we're really doing is applying our algebra skills of substitution, addition, subtraction, multiplication, expansion, and the likes to be able to solve our two equations.